Okay, the Unit 6 test review. This is all about triangle congruence. Remember, we learned an isosceles triangle, labeling the parts. The two congruent legs are called the legs, and the odd man out is the base. And then we have the base angles, and then we have the vertex angle. So the two congruent parts are the legs, the odd one is the base. We then have the base angles, which are the two congruent angles, and the vertex angle. Now we can use the properties of isosceles and equilateral triangles in order to solve for unknowns. The first one here, I see that it is equiangular, which means that, or excuse me, equilateral, which means it's also equiangular. So all three angles are 60, so I set 6x equal to 60, divide, and x is 10. In this one, I see it's isosceles, which tells me that these base angles would be congruent. I know the sum of the interior of any triangle is 180, so I have 180, and I'm going to subtract 96 for the two angles at 48, and that leaves me with x equals 84. The fourth one here, I again see that it is isosceles, so the base angles are congruent. I know that the sum of all three of these will be 180 degrees, and that would be 4x, 4x, and x, so I have 9 x's. X is equal to 20. This one tells me that the base angles are congruent, so I know it is isosceles and that these are the congruent legs. To solve for the unknown quantity, I simply set up an equation, x plus 35 equals 2x. Subtract from both sides, and I get x is 35. Again, I see the base angles are congruent, which means that these legs are congruent. It's an isosceles. And I set up my equation by setting the two legs equal to each other, and then I rearrange to solve. And I have A is 15. Final one here, I see it's equiangular, which tells me it is also equilateral. So all three of these are equal to each other. I see I have 15 here, so if I set each side independently equal to 15, I can solve for the unknown variable. And y equals 8. The second one here, I have x minus 3 equals 15. And x is 18. Now, we've learned this property that the exterior angle here is equal to the sum of the interior remotes. It doesn't work directly for this one. I do know that it is an isosceles. What I should know is that x plus 125 will equal 180 degrees. So that leaves me with x must be 55. Now that I know this is 55, and isosceles, I know this angle is also 55. I know that the three of these will total 180. So y is 70. Now this one works off the property the exterior is equal to the sum of the remote interior. So I know that 3x minus 22 equals 80 plus x. I'm left with x equals 51. Okay, congruence statement. What's important about it is that you list in the corresponding order. So, if I'm going to name these two triangles, I'm going to start over here at G. I'm going to go G, H, J. So triangle G to H to J is congruent to, Now I need to name it in the corresponding order. So the angle here, G, corresponds with J. So now I'm going to say JKG. And then do the same thing here. I'm going to start with ABC. So if you look at the angles, I have 3, which pairs up with 3 there. I have 1. B corresponds with B. Then I have 2. That corresponds with C here. So, triangle ABC, I went angle with 3 markings to 1 to 2, corresponds to triangle CDA. Okay, if you look at number 11, which of the combinations here does not refer to a theorem or postulate to prove that 2 triangles are congruent? There's 2 that we've talked about in class, one being AAA and the other being SSA. Neither of these are any good. The other arrangements of A's and S's are all fine. AAA and SSA are the only 2 that doesn't work, and I can see that AAA is right here. Again, the word there is does not. If I'm going to draw a triangle that's congruent to the other, okay, if I draw a triangle congruent to MNP, and I need to show it's congruent by AAS, that means I need 2 consecutive, I'll just label ABC, 2 consecutive angles. So we'll say angle A is congruent to angle M, B is congruent to N, and then I need the next side. So BN is congruent to NP. And that's all it takes. And there's various combinations that you could do this to show that this triangle is congruent to MNP by AAS. Okay, proving triangles are congruent. We've got 5 ways to do it. Side, 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 angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg. So when I look here at the information that I have, I see 3 sides congruent to 3 sides of another, so these 2 triangles are congruent by side, side, side. Here I just have 3 angles congruent to 3 angles, and I know that that is not one of my 5 ways to prove the triangles are congruent, so this cannot be determined. And then here I have that side, BD to FD, and then I have the angle between them. This would be side, angle, side. I have this leg congruent to that leg, AB to CD, and then I have BD's congruent to itself, so this would be side, side, side. Over here I have EB to CB, I have angle A to angle D. Then remember, whenever you have 2 lines intersecting, I created vertical angles. So if you look at the arrangement here, I have angle, angle, side. So these 2 triangles are congruent. This one I have an angle to this angle, the 90 to the 90, and then the 2 lines intersect and create vertical. So I have 3 angles that are congruent to 3 angles of another. So this one again is AAA, which is not one of the 5, so it cannot be determined. Down below, looking at 19, I have K is congruent to R, O to V, and then I know nothing else between them. So with simply 2 angles, this one again cannot be determined. Number 20, B is congruent to E. I can tell that from the marking there. C to F. And then I have BC to ED. So these 2 are congruent by the angle, side, angle. And first thought, whenever you have a right triangle looking for perhaps hypotenuse leg, in this case I do not know anything about the hypotenuse, but I do know that RQ is congruent to SQ. I know that TQ is congruent to itself, and then I have the angle here. If this is a 90, it intersects RS, so it must be 90 here as well. So I actually have side angle side. Side angle side. Here, I again have right triangles, MN's congruent to RQ. That would be the hypotenuse, and then I know that they share a common leg there, NO, so this one is hypotenuse leg. Again, I have right triangles, the hypotenuse are congruent, and then they share a common leg, so this is also hypotenuse leg. Here I have T and U congruent, N and H, and then the intersecting lines create the vertical angles. So this again is AAA, which is not one of our 5 means of proving congruence, so it cannot be determined. And the last few. I have angle Z to X. These are both right triangles, so those angles are congruent. And then I know that WY is congruent to itself. So this one is angle, angle, side. Here again on 26, TU is congruent to TS, SV to UV, and TV is congruent to itself. So I have 3 congruent sides, side, side, side. SN is congruent to SH. I know that these angles are congruent. They are vertical, and then they both have right angles. So this one would be angle, side, angle. Here again I have angle E is congruent to G, side FG is congruent to ED, and EG is congruent certainly to itself, so I have side, angle, side. Remember, what's important about side, angle, side is not simply any 2 sides in the angle needs to be included. So side, angle, side. 29, I have TS congruent to KJ, angles T congruent to K, and U congruent here. So as I move around the triangle, I see I have angle, angle, side. And the last one, this is a right triangle, and I have the hypotenuse, but it is congruent to the leg of another. I know that these legs are congruent. Then I do have congruent angles, but the problem is this is not the included angle. It would need to be in here in order to prove side angle side, which it is not, so this one again cannot be determined. And to finish up, we have our proofs. Remember, we typically have given information. These are just fill in. I see AB is congruent to segment CD and segment BC is congruent to AD. They have those markings already here. So the first statement says just that. AB is congruent to CD, and then BC is congruent to AD, and these were my given information, so I just plug in number 5 for given and given. AC is congruent to AC. I know that to be the reflexive property, just like looking in a mirror. And then the 2 triangles are congruent. What have we shown? Side, 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 which is number 3. And in the final one here, I have segment WU is parallel to YV. That was given information, so number 5. Angle UWX is congruent to VYZ, UWX to VYZ, and those are corresponding angles because of the the parallel lines, so that is number 3. I have segment XU is parallel to segment ZV. So I have XU to ZV, and that was given information, number 5 again. So we have angle UXW, so this angle here, is congruent to angle VZY, this angle here. And that again, if you were to extend these lines, and this acted as the transversal, those would just be the corresponding angles again. So that is number 3. And then we have segment WX is congruent to segment YZ. That was given information. And how were we able to show this? Well, I've got angle side angle. That is number 6. And then if we extended further to show that this piece were equal to that piece, we would use the CPCTC. Corresponding parts of congruent triangles are congruent.